A very warm welcome to you all from the Schaffhausen Institute of Technology. Thank you all for joining us today for this very special webinar to learn more about this innovative education model at SIT, and more specifically to enlighten you about the new master's program in computer science and software engineering. My name is Mark Barton, former news anchor on Bloomberg Television, and I'm very proud to be the host of today's webinar and to open your eyes to the ethos behind this unique course to create the next generation of scientific leaders. So we're very, very excited to tell you about this course today. We've got a very esteemed group of speakers for you today to underscore why this course is groundbreaking. As you can see, we've got Dr. Serguei Beloussov, the Acronis Chief Executive Officer. He likes to call himself the mother of this course. Igor Sysoev, who's Senior Architect at NGINX Business Unit F5 Networks, and the father of this new, unique MSc course, Professor Mauro. Pezzé. We've got a cracking agenda for you in the next hour or so. Here's the agenda. There's so much to look forward to. Before I tell you about the agenda, I want to just tell you a couple of things. At the bottom of your screen, you've got this wonderful Q&A function. Press the Q&A function, and throughout today's webinar, we'll answer your questions live. Our SIT team is sitting, waiting, eager to answer your questions. So please use that Q&A button at the bottom of your screen if you have any questions about this unique new Masters of Science course in computer science and software engineering. Don't forget, you can see it at the bottom of your screen as well. You can sign up to this course anytime. Find out more details at sit.org or at sit.org/admissions. And if you've missed anything of this seminar, if you want to look at it again, check out some of the slides, the speeches from our eminent speakers today. You will be able to catch today's webinar on the sit.org website. So it's a busy hour and a half. We've got Serguei Beloussov, we've got Igor Sysoev, we've got Professor Mauro Pezzé. We're going to have a lovely Q&A session at the end of the webinar as well. So please be courageous. Please fire those questions to us. As I said, not only will we answer them in that Q&A function at the bottom of your screen, but there will be a Q&A function, a Q&A session at the end of today's webinar, so we can answer in person some of your questions on this wonderful new course at the SIT. Now, there are 8 differentiators when it comes to SIT and this new masters. A key one, which I really want to stress, is entrepreneurship. Now, what separates this course from all the others out there is it teaches you to build, it teaches you to grow your high-tech business. And our first speaker knows a thing or two about building, about growing high-tech businesses. He's the founder of more than 24 companies around the world. His talk today is on the future of computing. And what it does is it highlights one of the strengths of the SIT model and this new MSc course. You've got access to the people who are shaping the future of science and technology. It gives me enormous pleasure to introduce the founder of the Schaffhausen Institute of Technology, Dr. Serguei Beloussov, the Chief Executive Officer of Acronis, and as I said, the founder of SIT. Sergey, I'll hand it over to you.
Sorry, every time I give speeches on our events, I'm trying to make this shorter and shorter speech, because this is probably 20th time. But in a nutshell, the first thing I wanted to talk about is that the world is eaten by computers. Everything in the world is digital, especially since COVID-19. Computers, computing, software, and hardware are eating the world. And digital workloads, they consist of ultimately zeros and ones, and they are becoming mission critical, but they are very, very fragile. And so they need protection. there are following challenges to protect those workloads from being copied, from being broken by bad guys, or from being broken by bad circumstances. One is that there's a lot of systems and a lot of workloads. Today, there are 50 billion smart devices. By 2030 is 500 billion. Two is there is a lot of cost associated with digital workloads. Today, there are 50 zettabytes of data. In 2030 is 500 zettabytes. One autonomous car can generate 4 terabytes of data per day, more than 1 petabyte of data per year. And so either you have too many users or too many devices or too many gigabytes. Security, of course, is industrialized and organized. And so really, you can change this picture from organized crime organization to a cyber organized crime organization, especially with the COVID-19. Even criminals had to adapt and have to manage their businesses through digital means and perhaps secure video calls. Then privacy is a major issue, because if you are not worrying about privacy of digital workloads, they can be copied and easily used to manipulate your decisions. And finally, everything in digital world today is becoming mission critical. If it's broken, you cannot function. We can see there is a lot of similarities between biological and computer threats. So biological threats, as we've learned with COVID-19 in a very vivid way, as if it was a movie, biological threats require prevention, detection, response, recovery, and forensics all together to make sure that the damage is minimized. Good hygiene, healthy lifestyle, social distancing on prevention side, a very good way to decrease number of severe casualties and decrease number of people sick. Detection, very important, as we've learned with COVID-19, very quick detection of who is sick, very quick detection who was sick and couldn't get sick anymore with antibody tests. Response, extremely important, having a good healthcare system, good general purpose health care, and strong immune system of your population. Recovery, very important as well. People do get sick and they need to recover in a way that it's most optimal for their health and for the financial and strategic health of their communities. And of course, forensic, because without forensic, you can actually not figure out how to do prevention. It is extremely similar for what can affect your computers. And just like with computer, or with biological viruses, it's not really important whether the virus is made by a human or whether it is actually somehow created by nature, or whether it's an accident, whether it has a biological, political, or natural disaster kind. You need to do all those 5 things: prevention, detection, response, recovery, and forensic, in order to make sure that your digital infrastructure is healthy. And in fact, when it comes to biological infrastructure, we are prepared to deal with such threats since thousands of years. With digital world, we're only learning. In Acronis, we believe that the only way to go forward is complete and integrated protection. And our mission is to protect all data, applications, and systems, which we collectively call workloads, from all 5 vectors of possible threats. Safety, nothing is lost. Accessibility, you can access everything from anywhere at any point of time. Privacy, you can control who has access and can control that the access is not misused. Authenticity, you can control that your data is original, and also you need to be, of course, secure and protected against bad actors. Considering the number of systems, it must be very easy to use. Amount of systems, the number of data, amount of data, it has to be very cost efficient, has to be very secure, controlled, and reliable at all times. And so with that, Acronis is building first in the history of digital world cyber protection platform. So it's a platform which is focused on protecting other platform applications and data from safety, accessibility, privacy, authenticity, and security standpoint, which consists of the product which is offered to the end customer, an ecosystem of managed service providers who manage it for the customer, an ecosystem of developers who built on top of the Acronis Cyber Protection and on top of Acronis Cyber Cloud, complete set of infrastructure and systems which enable our cyber protection, cyber cloud, and cyber platform to be very, very easy to use, efficient, controlled, secure, and reliable, and services. It's really very interesting endeavor. Acronis is not a huge company. However, it is a market leader in cyber protection. Artificial intelligence powered cyber protection, cyber cloud, and cyber platform. We are headquartered as a corporation in Schaffhausen, Switzerland, and we are have second international headquarter in Singapore. So we're Swiss Singaporean. Effectively, especially now, we've learned how important for a cyber protection company to have dual headquarter, to be dual protection. We are not very large company. We're about $300 million in billion, but we are growing very fast. And our goal is to grow 10x in 5 years, which will still not make us a huge company, but reasonably impactful. And this is our areas of expertise, which are relevant to what we do with SIT to some extent, what I do with SIT to some extent, cyber protection and cyber engine based on artificial intelligence, and with a significant focus on all of the vectors of SAPA, specifically security, computer science, software engineering, and engineering education. Acronis cyber platform, cyber infrastructure is a complete set of application and platform for protection. It's by now over 50 million lines of code and rapidly growing. We have 1,000 people in technology department, so we're a full-blown technology company. And we also have some specific expertise, again, related to artificial intelligence and usage of computer science and artificial intelligence and mathematics and modeling in various areas of human activities, such as sports, such as marketing and partnership. With that, I want to talk about other problems which face us, not just problems of digital world. Real world has real problems. And we believe that all of the problems in the world are solvable with better software and better computers. This is just example of problems. What we've learned today, diseases and aging, is something which is very, very real and can affect us anywhere we are in the world. Of course, COVID-19 to some extent is something which is in the past, but not really. It's also in the present, and it seems that it will last for a future. There are other problems. We believe that the ultimate way to solve the problems is with knowledge, and the best way to process knowledge is using a computer. We believe that the universe is a computer, and the laws of nature solve the software for this computer. And so you can model the universe and almost every process in the universe on a proper computer. So here is an example of such modeling related to making a vaccine for COVID-19 or something else. But you can basically model just about any process in the universe on the computer. Now, what is a computer? So digital computers are effectively equivalent to Turing machines. Today, we primarily use digital computers. And Turing machines are very simple one-dimensional devices which are created as an abstraction object by Alan Turing. And modern digital computers, which is what we use for solving most of the problems today, are effectively equivalent to such simple machines. So there are central processing units, there are graphic processing units, there are tensor processing units. They have slightly different architecture, but ultimately they are all effectively equivalent to Turing machines. And today we have 2D central processing units, GPUs and TPUs. We have new generation designs which are 3-dimensional, but there is no way to make them 4-dimensional. With that, we are reaching some limitations of digital computers, and there are a number of proposed up-and-coming designs to solve some of the limitations, such as specifically limitations of digital computers for deep learning. For example, neuromorphic designs, both in production level and some proposed designs like based on memristors and photonic computers. Ultimately, all of those computers are governed by the same laws of nature. And we know that, for example, for the silicon computers, there was a law, or rather an observation by founder Winter Gordon Moore, which was coined as a Moore law, that number of transistors and resistors on a chip double every 24 months. This observation have been predicted to stop for many years, and right now there is an organization which believes that we are effectively at the end of Moore law. And even with other designs of purely digital computers, you are going to reach performance and throughput limitation, power consumption limitation, transistor size limitations. And so, for example, an expert in computational complexity, Scott Aronson, in MIT University of Texas, believes that we're going to hit these limits in 25 years. There are fundamental hard limits which will be approximately hit in a longer period of time, but it's not clear we can reach them as well. Now, you would believe that computers are getting faster and faster and faster, and so most likely all of the problems of the universe can be solved already today. Well, not really. There are these two very conventional problems, many-body problem in physics, which would allow us to predict behavior of nature, physical matter, and large integer prime factorization problem, which is the problem which is used to enable public key encryption. And both of those problems cannot be resolved even in the this fictional computers as per Scott Aronson prediction. Because of that, there are a number of alternative designs, specifically quantum computers and other possibilities. This is a picture of Google record-breaking quantum computer, which has actually achieved for the first time in human history quantum supremacy, effectively making it possible to solve a problem on this computer which is impossible to solve on a conventional computer. There are many alternative designs designed based on cold atoms by one of our board members, Misha Lukin, designed based on ion traps by IonQ and Honeywell, and superconducting designs like Google, IBM, and Rigetti. What is interesting, we are right in the middle of the quantum revolution. If 10 years ago, it was not clear whether quantum computers are coming 10 years or 50 years from that date, today it's clear they are available to some extent today, and every year they're going to be 2 to 3 times better and faster. There are these very futuristic designs. Like, for example, you can make a very fast computer which can calculate digital numbers, process information 10 in the power of 35 per second, and based on black holes. So maybe finally we can leverage another institution, a research institution in Switzerland, CERN, make some small black holes and calculate things very fast. Or there is, of course, a possibility to use advanced materials computers. There are some startups which are already making better memory on these computers with some limited, perhaps, execution capabilities. Now, if we think about this particular type of computer, advanced material computer, we have an example of such computer which presents us one of the most interesting problems in the universe, and perhaps it's a most interesting object in the universe, and that is human body and human brain. Today we know that it's pretty special. You should think about it. It's 200 billion atoms in a single DNA, which generates through a set of strange processes 40 trillion cells in a human body. Part of human body is 100 billion neuron cells in our brain with 100 trillion brain connections, which actually has very low power consumption, and yet not very heavy, not very large in size, but it has a most superior creative capabilities to any computer which is existent in the world to date. And there are many fundamental problems about human brains which are related to human life and human existence, which on its own require better computers to be resolved. Now, there are many situations where this futuristic computer designs are very needed, are already very used today. For example, robot sensors and actuators definitely require much faster and much more special computers, much more flexible. Making new generation advanced materials or new generation data storage, or making real smart prosthetics parts of our human body, so effectively some very specialized robots. Or for example, what we've learned today, as we moved completely to a digital world, the only way for us to be private in this digital world is to use quantum internet. And in order to build quantum internet, we need a very specialized quantum computer, which is quantum repeater. In fact, the laws of physics and free choice are the only things which actually enable privacy. And there is a famous article by one of our board members on the cover of a Nature magazine, which is basically explaining that in order to keep a secret, you need to assume quantum entanglement and the presence of free choice. Neither of those are trivial assumptions. Now, the good thing about the computers today is that the adoption for new type of computing can be much, much faster, as new kinds of computing can coexist today in large deployments. For example, in Amazon, Google, Azure, IBM, iCloud, and so on and so forth. You can combine them with examples of such system interconnects. And so this is an example of fantasy mainframe with CPU, GPU, TPU, which already exist, memory photonics, and quantum computers, which almost exist, micro black hole, noise-free analog, and advanced materials-based computers, which might take a little bit longer. And in addition to that, human brains added to process information even better. So the deployment of those computers could be very, very fast as soon as they can be operational. However, in order to make them operational, new computers would likely require new advanced materials. There is many new advanced materials which were required for existing computers. New computers would require completely new hardware. Many of them do not look like existing computers at all. New computers will need a new software to design them. Modern CPUs have up to 1 trillion transistors. Of course, you cannot design such things without very specialized software. Modern computers would require new system software, and today we have Igor Sysoev, who is an author of NGINX. NGINX is a application delivery server and web server, which is used by basically everybody in the world, and it's an example of system software which is, however, built for digital computers. You will have a lot of things for the new generation computers, system software for new generation computers. And then, of course, you need the application software to leverage these advanced capabilities. Because of that, we decided to start, I decided, and my partners decided to start a new science, technology, and education cluster. That is a huge market, very significant portion of global GDP of human life on Earth is spent on science, technology, and education. We want to be focused on computers, physics, and business, and we want to build significant independent cash flow to fund our operation. The pinnacle of what we do is really science. In order to enable science, we need technology because technology generates enough cash to enable science. And in order for technology and science to work, we need humans, and so for that, we need education. In SIT, we want to stay very focused on just these 3 areas: computer, physics, and business, and some specific sub-portions of those areas: cybersecurity, information integrity, artificial intelligence, machine learning, software engineering, robotics and autonomous machine, quantum technology, and advanced materials. And there is a number of aspects how you actually leverage computer science and apply computer science and technology to conventional business processes. What is very important for us is to build it in a very interdisciplinary approach way, because we believe that modern products, solutions to the human problems are always requiring multiple discipline compliance together. Such a desired object as autonomous car. In SIT, we have autonomous car racing team, require, for example, all of those areas together to be enabled. So most of the areas which we listed are needed just to build a very simple thing of an autonomous car which would really work and will be able to drive fast. How are we going to do it? Really very simple. So first of all, we created a partnership. Well, first of all, we chosen Switzerland and Schaffhausen for a headquarters. Second of all, we created a partnership with Carnegie Mellon and National University of Singapore. Third of all, we have built a very strong strategic advisory board. Our chairman of the board is a Nobel Prize winner in physics, probably the youngest Nobel Prize winner in physics, very active in research. Kostya Novoselov, he is still just 45, and he is very much involved in advanced material research. Michael Lukin and Nicolas Jezan in quantum technology, Arthur Reckert, David Rosenblum, Mark Kamlet have different degree of relation to computing sciences, and Fabio Pomoli, Rina Rapuli, Sergei Nitesin applying technology and science to business. We also have a strong board of directors, strong executive board, strong industry board, and there is a lot of people who are leaders in science, research, and business, science, technology, and business, which are part of our friends network. Presence of these people enable us to reach the heights with our students. With that, we are going to be launching 3 interdisciplinary master programs, but in 2020, only one of them, master program of computer science and software engineering. There is a description of the program. I believe in this presentation today, Mauro Pezzé, the father of the program, will take over from the mother of the program and will describe it to you in a better fashion. I just want to focus on 2 important differentiators. The first differentiator is that typical technology projects, typical product development projects today always involve software. And the software engineering is never about one person building one product over 1 year, but typically it's 100 people over 10 years. So typically you're talking about 1,000 man years, typically you're talking about 10 to 100 releases, and typically you need 5 to 8 leaders which actually manage those 100 people and manage number of aspects of the operation of those people. And I described those 15 roles on the left side, which I believe are important for large and typical project in software and computing. This year, we are going to be focused on these 5 first roles: Chief Architect, Chief Product Officer, Chief Program Officer, Chief Development Officer, and Chief Security Officer. All of those roles require something beyond computer science and software engineering. And so this is a sense which we believe that's the second part leaders require. So the first is access to leaders and advanced people. In my career, I learned the most by working with advanced, driven, and very smart people. And our governing boards and our network will be actively involved with students, will be actively accessible to students. And I think this is an unbelievable advantage for every student in the program. We may be a new institution, but if you look at the people involved, the level of people involved is not less than any of the top 25 universities in the world. Then the second thing is entrepreneurship. Entrepreneurship is something which is complicated, and I was asked whether it can be taught. In my opinion, you can show it by example, and there are certain things which you can provide. Entrepreneurship is important whether you're building a new company or you're starting a new project within a large company. Then, of course, specific skills for those 5 roles. Some of those roles are relatively conventional, such as, for example, Chief Development Officer or Chief Security Officer, even though there are very many new aspects to how you need to work in those roles. Some of those roles are perhaps less known, especially for beginners in software engineering, computer science. Then another thing which is extremely important in software engineering is that software engineering is always about change. Change, stress, and multiple things at the same time is a common scheme of any high pressure technology and science project. And so you need to know how to manage change, because that's all you do, manage change. Science of people, understanding people and understanding human behavior. It's important for computer scientists and software engineers to understand business, and we want to teach business in the language of computer science. Modern business can be described as a game theory or as a mathematical and computer science model. A lot of the problems in business can be solved with the use of artificial intelligence. And then we're going to give two short overviews of physics where we have the most advanced expertise, quantum informatics and advanced materials. Again, in the language of software, the way we think about the program, it is 70% computer science and software engineering. It is 20% leadership and management and entrepreneurship, and it's 10% very special areas in physics. And with that, this is my last slide. So what can you do now? So first of all, you can become a Acronis customer, partner, employee, engineer, or executive. We are just 1,500 people, but we're hiring another 1,500 over the next 36 months. You can join SIT as a researcher faculty. You can invest or be a sponsor, help a student. And we are really looking for students. That's the most important reason for today's presentation. And why would you join us? Very simple, because in reality, you want to become one of those people on the right, Alan Turing, who is the ultimate computer science, John Bardeen, who is the ultimate physics scientist, and Larry Page and Sergey Brin, who build extremely successful business through the extreme knowledge of computer science and software engineering. Thank you very much.
Sergey, thanks very much indeed. By the way, everyone, you will have a chance to fire a question at the founder of SIT later on. After our last and third speaker, we're going to have a lovely Q&A panel with Sergey and our other two speakers. So please think of questions to ask our three speakers about this wonderful new course. And by the way, don't be shy. There's a Q&A function at the bottom of the screen. Press the button, fire a question. Our SIT team are waiting. They're eager to answer your questions throughout this webinar. Please don't be shy. Ask questions. There's so much information to tell you about today. Please, if you have any questions, fire that Q&A button at the bottom of the screen. Ask your questions. Our team are sitting eagerly, willing, ready to answer your questions as well. Do apply if you're keen. If you have any questions, sit.org is the website. That's where you need to head to apply for this unique new course, sit.org. If you want to get to the exact page, you go to sit.org/admissions. And by the way, if you turned up late today, or if you missed any of Sergey's wonderful speech, or you want to go back and listen to any of our speakers, read some of the slides, today's entire webinar will be available on the sit.org website. But please don't be shy. Use that Q&A function. We're waiting. We're eager to answer your questions. There are so many reasons why this new MSc course is unique. And the primary focus, of course, is to prepare to develop candidates, graduates for leadership, specifically within the IT, within the science disciplines. SIT, and this is the important thing I want you to take away today, SIT helps you to become a leader and to create a team of leaders as well. Now, one element of this course I know is going to appeal to our next speaker is the thesis. The thesis can be written on the student's experience in their own startup business. Now, what you have is you've got access to the SIT Tech Park to investors, or you can choose to use one of SIT's own business network partners, such as Acronis, Citrix, Microsoft, McKinsey and Company, as well as in the SIT leading research laboratories as well. I can't stress enough, this level of engagement with business is extremely rare in a highly technical master's degree from other prestigious specialist universities. Now, I want to get on to our next speaker. This is an incredible story. He's a perfect example of the types of people you're going to have access to and be influenced by at SIT and this wonderful new MSc. He's a software engineer. He's a system developer. He's got invaluable first-hand experience of what it takes to grow and ultimately sell a business. His talk today is from software engineering to a $670 million business. That's one big reason to join SIT. It gives me enormous pleasure to welcome Igor Sysoev. He's Senior Architect, NGINX Business Unit, F5 Networks. He's co-founder of NGINX as well. And, as if that wasn't enough, he's the original author of NGINX Server. Igor, I'm going to hand it over to you.
Thank you, Mark. I studied in Bauman Moscow State Technical University, and in 1994 I graduated with an engineer degree. 90s was a hard times in Russia for engineers, and I started to work as system administrator in a small trading company. The company changed names 3 times, so it doesn't matter to mention it. And I worked with Microsoft DOS, Windows, Novel Network, and FreeBSD Unix. And as my job duties, I implemented automated information system on using web technologies. And I so like the technology, so in 2000 I decided to leave the company. Nevertheless, the internet bubble burst, and I started to work in Rounder as system administrator. At the time, I started to develop NGINX web server as a hobby project. So I developed it about 3 years, and in 2004 I publicly released it for everyone on the BSD license. The popularity of NGINX grew, and so I will describe shortly what is NGINX itself. NGINX is a web server and proxy server that sit between your web applications and clients. It can effectively handle tens of thousands of simultaneous connections. So applications can offload the task to deliver content to slow clients to NGINX, and they can focus only on the task, produce this content. So in general, it can be called like content delivery, application content delivery. So popularity of NGINX grew, and at 2011, almost half of most visited sites in Russia used NGINX, and about 7% of most visited sites in the world use NGINX. So for all this, I'm engineer. I have no any business skills. I'm not entrepreneur by behavior. So for all these years, almost 10 years, I didn't think that I can run business around based on NGINX. However, in 2011, I decided to start the business based on NGINX, and I founded the company with 2 co-founders. It was Maxim Konovalov and Andrew Alexeyev. We raised several venture capitals from we raised several rounds of venture capital from different venture funds, and the last one was led by Goldman Sachs in 2018. In 2030, we hired our beautiful CEO, Gus Robertson. And after this, our company became a real international company with several offices, headquartered in San Francisco, office in Moscow, in Ireland, in Singapore, and in Tokyo. And eventually, the company was acquired by F5 Networks in the previous year for $670 million. And now I'm a senior architect in the next business unit in F5 Networks. So it was a technical part of my career, and now I would like to focus more on business part. As I said, I'm not a businessman. So 3 persons on the left side of the slide really run the company: Maxim, Andrew, and Gus. So without these guys, I was not able to found the company, because I cannot manage people. I can do marketing. I cannot sell products. So all what I did, I upload all these tasks to this person, these guys, and what I would want to say that SIT give you unique chance to combine your education. You can get not only technical skills, but also entrepreneur skills. You will understand how the business works, how it's important to understand all the business, and I hope that will allow you to run your own very successful business. Thank you.
Thanks very much, Igor. Igor there. Fascinating discussion on his journey, the journey from working for an oil trading company to selling a company for $670 million. Absolutely incredible. You'll be able to fire some more questions, by the way, at Igor in the Q&A session after this. So we're very much looking forward to that. Please continue to fire questions at the bottom of the screen. That Q&A function, that's the function where you can fire questions at us here at SIT, and all our people are standing by ready to answer your questions. Please fire questions at us. By the way, if you missed any of these speeches today, if you missed what Igor had to say, if you missed what Sergei had to say, please make sure that you go on the website, sit.org, where you'll be able to catch today's slides, today's webinar, and absolutely everything. And the most important thing, of course, is if you're keen in applying for this course, head on to the website, sit.org/admissions. There's so much to discuss today. We're going to move on now to our next guest, our next eminent speaker. Now, like I said earlier, there are 8 reasons why this MSc course is unique. Our next speaker is on the executive board of SIT. The reputation and expertise of the people on SIT's boards is a key differentiator. What they have is they have a genuine influence on the future success of SIT students, connecting them with their own networks in the computer science and technology industries. I mean, there are so many exciting elements of this course, such as how can SIT help you build hardware, algorithms, and software for quantum computers? How can they do that? Simple. Many people on SIT governing boards are working on the bleeding edge of quantum computing to build practical computing devices superior to anything classic. I want to also stress, and this is the element of this course that I love, it's the interdisciplinary nature of this MSc course. Just look at the focus on, say, advanced material sciences, solving hard computing problems for development of new advanced materials and using advanced materials to solve hard computing problems. I could go on, but I think there's a man who knows a little bit more about this course than me. I want to introduce Professor Mauro Pezzé. He's Professor of Software Engineering at SIT. He's the heart, he's the soul of this MSc, and he's here, of course, to speak about the university's new MSc program in computer science and software engineering. Mauro, I'll hand the floor over to you.
Oh, thanks you, Marco. Thanks a lot. Yes, my goal is to actually tell you about the master that I started with the help of the big team. I see your questions coming in. I see you actually are very interested in many different topics. Many of them will be addressed in the talk. You're asking whether you can, what are the requirements to access the master. You ask whether a bachelor is okay. Yes, a bachelor is enough to actually access the master. Better if it is in computer science or software engineering. We do accept people with masters with bachelor in different disciplines that can actually be trained accordingly. I see questions about scholarships. Yes, we do have scholarship. We want to actually award the best of you. And so if you are really good, and you can apply and you will actually succeed. I see questions about the contest that we just completed. Yes, we do have specific dedicated scholarship for the people who actually got the best performance in our contest. But let me actually go ahead and tell you a bit about the master before continuing. There are several issues or several reasons why to join the master. Okay, and I actually try to get through this. Okay, let me actually go through the seven reasons that I actually want to actually think. Okay, you think about. I think the speeches before mine gave you a lot of motivation to start the master. Okay, to start a master in computer science. The main question is why SIT? Why start a master at SIT? Why don't actually go to a different master? There are so many masters in computer science and software engineering around the globe. So what is special in SIT? Well, we have a few elements that we believe are really, really special. Okay, and why we are so special and others are not? Because we are new. Joining SIT means joining a completely new program. Now, I remember a long time ago, I talked to a colleague of mine and I asked, the same question. So why I should actually join your master, which is a new university, in a new topic, never seen. And you say, look, that's because if you start from scratch, you don't have any legacy behind. You can really build something which is new and innovative. You don't have to actually satisfy the millions or tens of professors who are very willing to teach you the classic topics. You can do something completely new. And that's what we do. We have a completely new program. A completely new program, which is actually a program that is not just computer science, it's not just software engineering. It's the only master, I believe, that blends the two disciplines, computer science and software engineering. We need science and engineering to build software. We have a completely new program that is not just technical. Actually, Igor was really clear in terms of, you need help. You need help. You can be the best technical guy in the world, and you can have the best idea in the world, and then you really need people to actually have business idea, and you need people to actually know how to actually lead a company, lead an enterprise, a team. And that's what we do. We have a unique blending between technical education, business education, and leadership. People. Sergei gave you a very, very good example of a long, long list of people. Yes, we do access top people worldwide. And it's not just Sergei, it's not just me, it's not just Igor, it's you. You as students will access these people. Teaching. Oh, it's easy to say, you know, we are in the coronavirus era, so yes, everything goes online. We are online right now, you know. No, this is not what we do. It's not just going online. Going online is easy, you know. You get a good account, you get a good system, and you blah, blah, blah on the web. No, we do completely different. We actually have a completely new technology to teach, which we designed before the coronavirus, which allow people to work in teams as in the reality. The reality is that right now you do not work in a team which is sitting in the same room, the same table every time. You work in a team which is sitting worldwide, and we start in a team which is sitting worldwide, and tell you why a bit later. Other enormous advantage, research and industry. Somebody asked about the double degree, about with CMU, with NUS. We do have top leading universities, which are our partners, work with us, come up with us, and give you access to double degrees. Yes, you can get 2 degrees. Give you access to people in that university, give you access to new courses. We also have extremely good access to leading companies in this environment. I myself, you know, remember a few months ago spending time with a technical guy from Williams race car, asking about how they actually measure the flow of air on the racing car in Formula One, and that was not just like a quick talk. I was sitting with the guy near the car to see how the sensors work, because that's what means access to leading people in industry. Okay, we do have a double degree. We mentioned that already, but that's actually very important. We actually joined. You know, it's not just like you get not just a double degree. You get an intercontinental degree. You get a European degree and a North American degree. A European degree and an Asian degree in top universities. And yes, we do have scholarship, because we do understand that what is important for us, for the company, for the university, for the country, is not to get the opportunity to people who can afford studying to study, but to give the opportunity to people who actually have the ability and the willingness to study. And that's why we have important scholarships. Now, let me actually give you a couple of more information about these 7 points. First one, I talked about an exciting program, okay? We mentioned that already. You need technical skills. You need to really be technically deep in different areas, but you also need to be able to manage, to do business. You also need to be able to actually have some leader, be a leader. And so technical skills is not just the classic software engineering, computer science master. We do have leading edge technology. It's quality engineering, data science, cyber protection, architectural structure, deep learning, software engineering, quantum informatics. So basically, we actually get to the point that we merge together all what you need to know, and it's very unlikely you got it in the bachelor. So you need a strong bachelor, but you can actually get much more than the bachelor. Management, you know, management means product, means process, means design, means transformation, means being in an evolving and transformational market. Leadership, being able to build your own company, being able to actually be a leader in a company, being able to actually look at how the company works. We study agile leadership, we study customer-centric mindset, we study human social psychology. We also have another element, which is leaders in research and business. Okay, well, you can say it's me. Yes, it's me, actually. You know, I don't want to step back. You know, I am the editor-in-chief of HCM Transactional Software Engineering and Methodology, which is one of the 2 top leading journals in software engineering. I am the co-author of an important influential book. I actually graduated 25 PhD students. They are now full professor at Georgia Tech, top university in US, that are now professors in Politecnico di Milano, top university in Italy, that are leading scientists in India, top centers for cybersecurity in Spain. So it's access to, I actually did my best to actually build a program that gives you access to whom? It gives you access to many other people, It is access to give access to Serguei. We actually saw Serguei. You know, it's a person, or it's a leader who actually built a billion company and is leading a billion company value. We give access to René, who is the third top highest paid marketing executive. We give access to Barry, who is one of the most important experts of human polygraph. We give access to Arthur, which is professor on quantum physics, leading in how to actually use quantum physics to get quantum cryptography. We give access to Anton, who is a professor of operational decision science, how to actually manage in an agile way. We give access to Candid, who is the lead of a global Symantec security response team. It's actually the one who is working on a Symantec security. We give access to many people: Stan, Bruce, Kostya, Nobel Prize winner. So you get direct information. You know how you actually these people got the leadership, and you can actually talk to them directly. Third element, teaching style. That's tough to explain, you know. I actually mentioned that as agile, flip learning, blended, distributed learning. What does it mean? Okay, it does not mean that I sit in my classroom and speak and you listen to me online or offline. No, it means that you sit with me, with the TA, with your mate in the classroom all together, but doesn't have to be physical sitting, it needs to be mental sitting. You sit in the class being physically in Schaffhausen, or being in Carnegie Mellon, or being in NUS, or being in Moscow, or being in Madrid, or being in London, or being in Kyoto. You sit with us. You sit with us through the internet, and you work with us actively, exactly as you do while working on a team in a company. You know, when you actually think about Google, they have labs all around the world. There are people working in Europe, in North America, in South America, in Asia, in Africa, all for Google. They don't move every single day to actually meet together. They actually do meet together every day, and they do work together. That's what I mean when I say actually the online remote working teams. You will work and lead and study in this unique way, which allow us to go beyond the border of the limitation of the infection, beyond the limitation of restriction, beyond the limitation of physical presence, even beyond the limitation of visas. We actually sit down all together in the intellectual way. We're talking about direct access to world-leading research centers, not just the leading people, but the research centers. You have direct access to the growing reality of SIT. We get access to the software engineering lab, to the software quality lab, for the new coming cybersecurity lab, to the AI lab, to the robotics lab, to the quantum technology labs, to the advanced materials. Not all of them are in SIT right now. In many cases, we actually rely on our collaborators or friends, but yes, you will be sitting with us and you will be accessing academic research labs in SIT and in the partners universities. You have what is called a full-fledged industrial experience, which is not just during the master, not just as after, but before, both during and after the master. What does it mean concretely? Because it's easy to say, yes, we do have a lot of possibility to work with industry. Yes, but it means that the master has a specific activity, which we call capstone project, where people sit down with us and work on projects, problems that are given to us by industry. So it's actually currently hard industrial problems that we want to solve with you in the courses. So you see how to apply what you learn into the course directly. Internship, you know, we do have a very big network, and everybody will be given the opportunity to spend the summer in a company, getting the direct hands-on experience. One thing which is unique, every university today has a research thesis. Every university has industry thesis. So you do a thesis on a research topic, you do a thesis on an industrial project. We do have a third kind of thesis, which nobody else does, which is called startup thesis. You can actually design and create your own startup. which is not just a plain simple exercise. You design a business plan around an idea and you get a good grade. No, you get access to people who are leading in venture capital funds. You get access to people who are leading in the team organization. You get access to the startup or the incubator or the technology park of SIT, where you can actually not only see your thesis awarded, because a good thesis for creating a company, but you can create and build your company if it's really strong. We have access to industry leaders. We have access to privileged career opportunities. We give you the opportunity to learn what really you want to actually be able to access. We want to really give you the opportunity during and at the end of the master to actually get interviews with leaders, companies worldwide, in the region you prefer, in the area you prefer, and get privileged access if you're good, really good in that. And you will because you will be actually our graduate. We are talking about programs. We have one program. We have one master, which is a Master of Science in Computer Science and Software Engineering. But we do have additional opportunities. We do have what we call fast track. We do have what we call double degree. What is a classic program? 4 terms, study, internship if you want, study, thesis. Or you can actually move the thesis within the 2nd and the 3rd semester and within the summer. And so it's called the fast track. During the 1st semester, if you're really good, you can apply to that and you can finish in 3 semesters instead of 4. We are talking about the double degree. 1 semester at SIT, apply to the double degree. 2nd semester at SIT, get ready to move to North America, get ready to move to Singapore, get ready to actually get 2 degrees with 1 year in SIT, 1 year in the partner university, and a summer thesis at the end. How much it costs? What do we have? Well, we do actually have a program which is accessible to everybody, but we do also have a couple of very important elements, which is facilities and scholarships. Admission, very simple. You have a bachelor, go to our website, fill out a form, and you will get a couple of more requests for a couple of more documents, and your application is filed, and if you qualify, you are admitted. We need you to apply as soon as possible, because especially if you are a student with non-EU visa, just because we need to actually get you a visa for you to come to Schaffhausen. We also would like everybody to apply before the beginning of the master, which is September 1st, especially if you have an EU visa. You can apply to the fast track or the joint degree during the 1st semester. So once you actually get admitted in the master and you actually perform in the master, you can apply and get elements. We do have scholarship for everybody. We have this fantastic facility, which is you pay the 1st semester, you get a very good grade, and you get exempted for the 2nd semester. You continue with the good grade and you get exempted for the 1st semester. So we really want the best students not to actually be limited by the fee. And we also have scholarship that pay full scholarship to go to North America, full scholarship to go to Asia, full scholarship to stay, and part scholarship to stay with us in SIT in Schaffhausen. I've seen some questions coming in. We do have the opportunity now to go for more questions. I have a question for you if you want to actually continue, which is, okay, I have 2 questions for you. Question number 1, what is the best opportunity you see to come to SIT? Why you would actually choose SIT? And the second one, what is the best limitation you see for not coming to SIT? So that I can discuss it with you in the question and answer section and give you some hints about that. Thank you.
Thanks a lot, Mauro. There's so much to unpack there. It's Q&A time, audience. Thanks for sticking around. This has been such an eventful and interesting webinar. It's our Q&A section. Sergei's here. Igor, please put on your microphone just so we can hear you. Mauro's here as well. I'm here too. This is your chance to fire questions at our panelists to find out more about this unique new master's course, which SIT, of course, has just launched under a month ago. Sergei, if I could start with you, I've got a question here. How much of you is a leader? How much of you is a manager? And how much of you is a technologist? Sergei, don't think we can hear you.
I don't think there is a good answer to this question.
There you go.
Do you hear me?
Yeah, I can hear you now.
There is a different circumstances. I think if you want to build a technology business from $0 to $1 billion, or from 0 to at least $100 million, and even from 0 to $10 million, you need to adapt to different roles. So initially, you need to be a technologist because you start from technology, and then you need to be a leader because any small team which is entrepreneurial, you need to drive as a leader. And then as the company grows, you need to become a manager. And in different circumstances, you need to be different people. So you need to be sort of a chameleon. One of the favorite animals of mine, which is actually quantum technology-based animal based on quantum nanoparticles, it's chameleon.
Thanks, Sergei. And by the way, everyone, please continue to fire questions down below. You know the Q&A function. Press the function. You can fire a question at me, and I'll ask one of the questions to Mauro, Igor, and Sergei as well. Mauro and Igor. Mauro, let's ask a question to you. Let's please put your mic up. There you go. Mauro, great question here, which many people have asked. What really differentiates SIT? Because many other courses, colleges, institutions are saying the same things as SIT. They're using the same terms. Is there a true differentiator between all those wannabe universities and this new SIT course?
Well, you know, I have a long list of 7 differentiators, but let me say only one. We are new. I think this is by far the most important element in terms of what is the difference. Being new means we can actually do everything. You know, I think you can pick every single differentiator which actually listed. You can find it somewhere, but you don't find all of them all together. So I think what we really have as a unique opportunity, which is not available to anybody else, is it's not just, you know, new program, is not just access to people, is not just access to industry, not just access to research, is not just scholarship, is not just double degree, it's everything together. And we can do that because we are new and we actually are ambitious. We want to actually be the leader worldwide. And this makes a difference with respect to any other university where, yes, they can have access to the industry, but no, they don't have access to the right people. Or yes, they do actually can access to the different the network. They are very famous, but yeah, it's very expensive. So we actually put everything together in a unique box, which is the only one that you can find online.
Yeah, and if you're interested, please apply sit.org/admissions. That's where you head to. Any questions as well? If you have any queries, if you're thinking, oh, I don't quite understand something, you can always go to the website, sit.org/admissions. And of course, that's the website where you'll find all of this webinar. If you've missed any speeches, slides, nuggets of information. There have been so many nuggets of information. Igor, got a question for you from one of our audience today. Thank you for your great story, the audience member says. What was the reason, Igor, please put up your microphone. What was the reason why you've never studied abroad? That's the question. What's the reason why you've never studied abroad?
Well, the main reason, probably it's questions of a relatively young person. In 90s in Russia, it was not completely obvious that study is really available. Many my course mates just sell on the markets jeans, boots, etc. So I prefer to work on my what I can do, but I don't like to sell jeans on the market. So the main, I have never goal to get some degree, something like PhD or MBA. So I was simply not interested in it, and I like to work. And there is another career things that after Soviet Union collapse, I have no citizenship for several years, because I have no permanent residence, not in Kazakhstan where I born, and not in Russia. So I simply have not passport to travel abroad. Of course, if I really wanted to do it, I can resolve this issue, but this is one of the problems, that I can simply move from outside the country, outside Russia.
Thanks, Igor.
But the main reason, I simply don't want to get this.
This is Sergey. I just think there is a sort of three comments, very short. One of them is that SIT and the sort of kingdom of knowledge doesn't have borders, so you cannot really study abroad or in some place you study knowledge, and you don't have to grow abroad because there is no borders. Second of all, I want to point out that at the time when Igor studied, I don't want to be offensive, we are the same age with him. The universities in Soviet Union, they were very, very good. They were some of the best. In fact, Igor studied in a Bauman University. He joined it in 1988. Same year as I joined FISTech, and this was one of the top 100 universities of the world for sure, if not one of the top 50. In some area of definitely, like for example, nuclear science and some computer security is one of the top 25. This is very different if we are talking to people, for example, from Soviet Union, from what it is now. Right, and then also even forgetting the fact that Soviet Union was just collapsing when Igor joined, not yet collapsed, in fact, still very close, and even the world was much less global. So the borders, even in this not world of knowledge, but the world of the world where we lived in 1980s, actually, it was not open. It was not open not only for people from Soviet Union, but also for people from China or for people from India. It's a very different situation now, even with COVID-19.
Sergey, thanks a lot, gentlemen. I wish we had more time. I've been told we have to finish at 1:15. It's just a minute over 1:15. Sergey, thank you so much. Igor, Mauro as well, for your fascinating insights. So much wonderful information today about the unique education, the methodology at SIT, and this wonderful new MSc in computer science and software engineering. If you have any other questions, go to the website, sit.org/admissions. Our team are there day and night, ready to answer your questions. We're very excited to hear from you. And thank you, by the way, for all your questions today. And thank you for being here. If you missed any slides, if you missed any nuggets, there have been so many, go to the website. This entire webinar will be available on the sit.org website. Just want to tell you about a couple of events we've got coming up before I say a final goodbye. 2 events I want to tell you about. June the 30th, another SIT Masters Insights. As you know, we've got this wonderful new computer science and software engineering MSc. Join the webinar, learn more about the innovative education model at the Schaffhausen Institute of Technology. The event will be in Russian. Click on that link below. And just something further ahead, but we've always got to look further ahead. There's lots to look forward to. SIT Insights in Technology Annual Conference. Stick it in the diary, November 12th, November 13th, 2020, for science, for business, for students. We've got world-class speakers lined up. This event is your access to the latest technical developments and educational changes. sit.org/events. Just want to thank Sergey once again. Thanks, Sergey. See you soon. Igor, Thank you so much as well. And thank you to Mauro as well. Thank you to all of you for sticking around, for joining us for this entire webinar on the wonderful new master's course in computer science and software engineering. If you have any questions, don't be shy. Go to the website, sit.org. And if you want to apply, please do so. We're so eager to hear from you. sit.org/admissions. It's bye from me now. I'll see you all soon. Thank you all very much for joining us today.